On September 21, 2003, a spacecraft traveling at 108,000 miles per hour deliberately crashed into Jupiter, vaporizing in seconds. This was no accident. It was the final act of the Galileo probe, which chose suicide over potentially contaminating Jupiter's moon Europa with Earth bacteria. But before its dramatic death, Galileo rewrote our understanding of the solar system, discovered oceans on multiple moons, and sent a probe into Jupiter's atmosphere that recorded its own destruction in real time. This is the story of humanity's first permanent ambassador to Jupiter, a mission that nearly failed before it began and ended up changing everything we thought we knew about life in our solar system. Galileo should have launched in 1982. It didn't leave Earth until 1989. Those 7 years of delays nearly killed the mission before it started. Originally designed to fly directly to Jupiter in 2 years using a powerful Centaur rocket, the Challenger disaster in 1986 changed everything. NASA banned the Centaur from the shuttle cargo bay. Too dangerous, too much liquid hydrogen. Galileo needed a new plan. The solution was ingenious and insane. Use a weaker solid rocket and steal energy from planets. Galileo would fly to Venus once, Earth twice, using gravity assists to build up speed. A 2-year journey became 6 years. The spacecraft, designed for a short trip, now had to survive triple the time in space. Engineers called it touring the solar system on fumes. But there was a bigger problem. Galileo's main antenna, a gold-plated umbrella 16 feet wide, had to stay folded during the Venus flyby to avoid heat damage. It would sit closed for 3 years instead of 6 months. Nobody knew if it would still open. Spoiler alert, it wouldn't. October 18, 1989. Galileo launches from Atlantis's cargo bay, finally heading to space after years of redesigns, budget battles, and political fights. The spacecraft weighed 2,223 kilograms and carried 118 kilograms of scientific instruments. It also carried 925 kilograms of propellant and 2 RTG nuclear batteries containing 34 pounds of plutonium, making some people very nervous about launching it on the shuttle. April 11, 1991. After swinging by Venus and Earth, Galileo attempts to unfurl its high-gain antenna. Motors whir. Nothing happens. They try again. Nothing. The antenna is stuck, crippled, useless. 3 of its 18 ribs are frozen, probably because lubricant dried out during the extended journey. Galileo's main communication system, designed to send 134,000 bits per second, is dead. Mission over? Not quite. Galileo has a backup low-gain antenna, but it transmits at 10 bits per second. That's 13,000 times slower. Sending one photo would take months. The entire mission's data would take decades to transmit. Engineers faced a choice: give up or get creative. They got creative. For 2 years, they rewrote Galileo's entire software while it flew through space. They invented new compression algorithms, increasing effective data rates to 1,000 bits per second. They taught an old spacecraft new tricks: onboard data processing, selective image compression, intelligent data prioritization. Galileo became the first spacecraft to get smarter after launch. The team developed something called contingency science. Instead of sending everything, Galileo would analyze data on board and send only the most important findings. It would become its own scientist, deciding what Earth needed to know. This software upgrade, transmitted across millions of miles, saved the mission. Before reaching Jupiter, Galileo did something audacious. It gave birth. On July 13, 1995, it released a probe the size of a large barbecue grill, aimed directly at Jupiter's atmosphere. This probe had one job: fall into Jupiter and report what it found until it died. The probe had no parachute for backup, no retro rockets, no second chances. It would hit Jupiter's atmosphere at 106,000 miles per hour, the fastest any human-made object had ever traveled. The deceleration would generate 230 Gs, enough to crush any living thing into paste. The heat shield would face temperatures twice as hot as the Sun's surface. December 7, 1995. The probe slams into Jupiter's atmosphere. In 2 minutes, it decelerates from 106,000 Darwinton pH to 215 PO. The G-forces are so intense that the probe actually shrinks by an inch. Its heat shield, made of carbon phenolic, ablates away exactly as designed, losing 150 pounds in 2 minutes. The front surface reaches 28,000 degrees Fahrenheit, hotter than the surface of the Sun. At precisely the right altitude, the parachute deploys. The probe begins its 57-minute journey into hell, transmitting data to Galileo orbiting above. It discovers Jupiter's atmosphere has almost no water, shocking scientists who expected clouds of water vapor. Wind speeds reach 450 mph. The probe detects massive lightning bolts 1,000 times more powerful than Earth's. It finds strange noble gas concentrations, suggesting Jupiter formed far from its current orbit. As it descends, the probe experiences Jupiter's true horror. Pressure increases to 23 Earth atmospheres. Temperature rises to 305 degrees Fahrenheit. The probe's electronics begin failing. Its last transmission comes from 100 miles below the cloud tops. Still falling, getting hotter, signal degrading, then silence. The probe continues falling for hours more, eventually vaporizing completely, its atoms becoming part of Jupiter forever. While its probe died in Jupiter, Galileo began discovering wonders that would change astrobiology forever. Europa, Jupiter's fourth largest moon, was supposed to be a dead ball of ice. Galileo's magnetometer found something impossible. Europa was bending Jupiter's magnetic field in a way that only made sense if it had a global ocean of salt water beneath its ice. The implications were staggering. Europa has more water than all Earth's oceans combined, hidden beneath 15 miles of ice. This ocean is kept liquid by tidal heating. Jupiter's gravity literally squeezes Europa, generating friction heat. Where there's liquid water, there could be life. Galileo's cameras revealed Europa's surface, a shattered landscape of ice rafts, ridges, and chaos terrain, suggesting the ocean below regularly breaks through. Dark lines crisscross the surface, possibly organic material from the ocean below. Some images show geyser-like plumes erupting 125 miles high, spewing ocean water into space. But Europa wasn't alone. Galileo discovered that Ganymede, the solar system's largest moon, also has a subsurface ocean, more water than Europa. Callisto, too, showed signs of a hidden ocean. Suddenly, Jupiter's moons weren't dead rocks, but water worlds, each potentially harboring life. The habitable zone had just expanded beyond anyone's imagination. If Europa was ice and water, Io was fire and brimstone. Galileo caught Io's volcanoes in the act, massive eruptions shooting sulfur 300 miles into space. One volcano, Tvashtar, created an umbrella of gas 1,200 miles wide. Galileo flew through one of these plumes, its instruments screaming warnings as sulfur particles sandblasted its cameras. Io is literally turning itself inside out. Tidal heating from Jupiter melts its interior, creating 400 active volcanoes. Galileo watched mountains collapse, lava lakes overturn, and entirely new volcanoes appear between visits. The surface changes so fast that maps become obsolete in months. Galileo discovered Io has an iron core and generates its own magnetic field, unexpected for such a small moon. It found that Io acts like a generator, its motion through Jupiter's magnetic field, creating 400,000-volt electrical potential. Lightning bolts of electricity connect Io to Jupiter's poles, creating aurora displays. Io isn't just a moon, it's an electrical power plant. Galileo revealed Jupiter as a miniature solar system with secrets nobody expected. The Great Red Spot, that iconic storm, extends 200 miles deep into the atmosphere, far deeper than predicted. It's not just a surface storm, but a fundamental feature of Jupiter's deep atmosphere, possibly powered by internal heat. Jupiter's rings, invisible from Earth, turned out to be constantly replenished by micrometeorite impacts on small inner moons. Galileo discovered these source moons, Metis, Adrastea, Amalthea, and Thebe, being slowly ground to dust to feed the rings. Jupiter is literally eating its own moons. The radiation environment exceeded all predictions. Galileo's electronics, hardened against radiation, still suffered. Memory chips flipped bits randomly. Cameras developed dead pixels. The spacecraft aged visibly with each close pass to Jupiter. Engineers learned to work around damaged systems, commanding a slowly dying spacecraft to keep exploring. Galileo discovered that Jupiter generates twice as much heat as it receives from the Sun. It's slowly shrinking, converting gravitational potential energy to heat, still cooling from its formation 4.5 billion years ago. In essence, Jupiter is a failed star, not quite massive enough to ignite fusion, but still glowing from primordial heat. By 2003, Galileo was dying. Its cameras were radiation damaged, its tape recorder failing, its fuel nearly exhausted. But it had one final duty: protect Europa. Scientists realized Galileo might harbor Earth bacteria that survived launch, space travel, and radiation. If Galileo crashed on Europa, it could contaminate a potentially habitable world. NASA made the ethical choice. Galileo would commit suicide. On September 21, 2003, they commanded it to dive into Jupiter, ensuring any Earth microbes would be vaporized. Galileo spent its last hours transmitting data about Jupiter's inner magnetosphere, information obtainable no other way. The final plunge was violent. Galileo accelerated to 108,000 miles per hour, its components melting, then vaporizing, then becoming plasma.